Let us look at number 39 from chapter 10, section 4. So this, when you look at this one, a satellite is an elliptical orbit around the Earth, okay? And then the center of the Earth is at one focus. So this would have been one focus right over here. Then another focus would have been around here somewhere. It's not, exact, but somewhere here in the middle would have been the center. Now, in this way, it's 140 miles. The other way, it's 440 miles. Assume that the Earth is just a sphere, perfect sphere, with the radius of this much. Now, then, what's going on here? So if I were to sketch this one a little bit, it would have been something like this. Now, I'm exaggerating a little bit, but Earth would have been somewhere in the middle. So let us say this is the center of the Earth. And then if I were to draw the circle, once again, this is not exact description, but it's not in scale. But we're going to assume something like this. What they're telling us is the radius is 3960 miles, and then this one is 140 miles. That's 440 miles. And then of course this one is also 3960. Then you can see that the distance from here to here will be the same distance from here to somewhere. So I understand, once again, this one is not quite drawn in scale, so if I were to do that, it would have been something like this. So that focus, this is one focus, that's another focus, and then there's a center. So from focus to the end would have been 3960 plus 140. So we get 4100. That means this one also has to be 4100 as well. Now, another thing then, how about from the center to here? Center to here becomes entire distance divided by 2. So then we get entire distance is 45. Actually, I have to add another 3960 there. So entire distance would have been 8500. And then we got to divide it by 2. So 4250. So that's where the center is at. And then another thing that they mentioned was center of the Earth is at the origin. So in other words, if I were to imagine this is the x-axis, and that would have been the y-axis over here. Since from here to here is 4100, and from here to the center of the ellipse is 4250, then you get to realize that that distance is 150. Meaning center of the ellipse would have been at -150, 0. How does that help us? That gives us the equation of x plus 150 squared plus y squared is equal to 1. I just need to find the denominators now to complete the equation here. Now, denominator for the x is the horizontal differences. or half of the major axis in this case. Since the half of the major axis is 40 to 50, that's how much I'm going left and right by. So the denominator would have been 40 to 50 squared, which will be 18062500. Whoosh! That's a huge number. How about half of the minor axis? What's the distance that it travels vertically up and down? In fact, one thing that which we get to realize is that we can use the distance of C. C is 150, which is square root of, in this case, a squared minus b squared. So if I were to use b as the minor axis length, right over here, half of that, then you get to realize that b, in fact, or b squared rather, is equal to a squared minus c squared. So a squared we already found out 1806, and the minus c squared is what? 150 squared. Then we get 1804 0000. Okay, 1804 0000. So that becomes our equation of the orbit of the satellite. All right, I'll see you later.